Hey, welcome everyone. This presentation I'd like to explain a bit about React and whether React is reactive or not. So who am I? My name is Maurice de Beijer. I'm a developer, trainer, coach, mentor. I've got a couple of Twitter accounts. The main one is Maurice de Beijer. If you watch that account tomorrow, you'll see a tweet where I'll post my slides online so you can see them later. If you're interested in React, the other one is actually the more interesting because that's where I tweet all sorts of stuff about React articles and other stuff which is interesting to read if you're more into React. But just remember the first one and you'll find the slides, and it's actually the last slide as well. So what am I going to do? I'm basically going to focus on one question. Is React reactive? And just to get a sense of what I call reactive, I use ReactJS, and it's kind of, this is what I think of reactive. We've got a stream of data, we use one or more operators, which results in another stream of data. And the kind of code which is associated looks somewhat like this. So we've got an Rx observable and basically fetching some data from the movie database and playing around and concatenating different pages together. Not really important what it does, but that's the kind of code I think of as reactive. If we start looking at React and take a really simple React component, it looks something like this. So we've got a function here, and it takes an input argument, props, and it returns some markup. So if you squint at this, well, you could imagine props being a stream of properties being sent in, and this returns maybe a stream of markup. So if you squint at it, you could imagine this would possibly be reactive. Now, whether it is or not, I could just say yes or no, and we could go back to pizza, but what's the fun in that? So let's take a little closer look at React and what it really is. So React is this thing which comes out of Facebook, and it's basically meant or created for building user interfaces. And lots of companies have adopted it, including Zoover, of course Facebook itself, Instagram, but other companies like Uber, Airbnb, Netflix, lots of companies are using it. And if you want to get started, there is this utility. You basically install Node and then you install Create React app, and it's kind of your quick and dirty, well not so dirty hopefully, but quick way to start a new React application. And when you do that, you get all of this beautiful application. It's not very impressive, but there is actually quite a bit of tooling behind this. I'm not going to explain all of it, but you'll see some of it through the slides. So it does save quite a bit of time, and it's quite a nice way to get started. So one of the things you'll notice is React, it's built for the web, so it's JavaScript, HTML, and CSS. But the typical React application is not written in plain JavaScript. It's written in JSX. And JSX is a combination of markup and JavaScript. And it kind of looks like this. So we've got a function here assigned to a variable greeter, and it's just like I explained in the previous slide, it takes a properties input and it returns markup. Now this kind of looks like it's a template and there will be some merging going on, but in fact it's not. All of this is going to be transpiled. We typically use Babel for that, and a Babel plugin called the React Loader. And it will transpile all of this into pure JavaScript. So there is no markup there is no merging of tags going on, etc. All of that is turned into JavaScript. This function will actually return what they call a virtual DOM object. That virtual DOM is just a description of what the DOM looks like, and then at runtime that will actually be rendered into the DOM. These curly braces, they kind of denote expressions. So this will return hello, and then it will look at the props object and look at the name property there and take the expression and render that. This is a real simple component, about as simple as they can get. They typically are much more complex in this, and there's typically a lot more to it. But it's a place to get started. So, if you start building a React application, you really have to start thinking in terms of components. Now, when you start thinking about components, you kind of get this. We've got our application, which has one root component, and depending on the logic, it's going to show, in this case, one of three different. This is kind of a simplification of what Netflix looks like. So if you start Netflix, you get a login page. After you log in, you get that main page with a big list of movies and series you can watch. And there is a header there is a billboard movie, and there is a list of genres and movies, what they call the Lolo mode. But it's really a big tree of components. And if I look at this and I think about reactive, this doesn't really look very reactive to me. One component, okay, but a big tree like this, reactive, well, maybe, maybe not. Doesn't really look reactive to me. So what do components look like? Well, here's a slightly more complex example. In the previous one, let's skip this part. The previous one, we just had a function, but in this case we're actually using a class. We're extending a component, which is a native React type which ships with React. So it's a lot more complex already than just a simple function. In this case, I've only included a single function, render, which is called every time we need to know the markup for this component. But it turns out if you start using classes like this, there is a whole life cycle around it. Component will mount, component did mount, component receives props, should component update. There are a whole bunch of lifecycle functions which are called in the lifetime of a React application. And if I look at that, well, it starts feeling even less reactive. It's very stateful, I've got an object and lots of stuff is going to be called on it. It doesn't really feel like a stream of data or events coming through and the application reacting. Of course there are events, and we react to them, but not the same way. So all those components are nice, but they still need to end up in the DOM tree somewhere. The DOM tree is basically the big thing you see if you open up the HTML page. DOM elements. Well, it turns out React is kind of agnostic about how things should be rendered. There is this thing called React Native, where you can actually tell React or React-like components to render as native Android or iOS objects. There's even a version for that for Windows objects. But if we talk about the browser, the thing we get to is React DOM. And React DOM basically knows how to take the big tree of components, the virtual DOM objects that result from that, and render them in the DOM. So the code kind of looks like this. We've got the React.create element here, which basically says, okay, go and create me that whole big component tree for the application, and then render it somewhere using document React DOM.render, and where, well, we've got document.get element, get me some elements from the HTML page, and make that the root of our application. You can use React on the server using server-side rendering. Of course, then you wouldn't use this, but there is actually another version of React DOM, which we render it to a big string, which you can use on the server, and then return that to the client, so you get slightly faster rendering, at least faster first-time rendering on the client. So you can do lots of different stuff with React, depending on your use case. So we've got components. Well, I mentioned props, but I kind of left out what props are. It was this thing in parameter of the first component function. It was there on the second component, the class, although I didn't really look at it in details. But props are basically the input for React components. Think of it, if you think of a React component as a function, the props is basically the list of parameters. There's always one prop object being passed in that contains whatever parameters you have. And however you use them, you should never update them. So they're kind of immutable. They're not technically speaking immutable. JavaScript, it's loosey-goosey and nothing is really immutable. Although you could use something like immutable.js or object.freeze to turn them into immutables. But whether they are or not, you should never ever change anything on there, just read from them inside your components. And those props are basically how data travels through the component tree. If you look at this, I've got two components. This is the parent component. You can see in here there is a collection of movies. So we basically call movies.map, so the standard JavaScript way of mapping items. And for every movie object, we say we'll render a movie component. So the movie component here with angle brackets. And pass in two properties. One, the key, which is a requirement of React. As soon as you start rendering repeated elements, they should have a unique key. And additionally, just pass in that movie object to that component, and it can figure out what to do with it. So this component only knows about rendering lists of movies. It doesn't know what those movies will look like or how they're going to be rendered or anything, but it just knows how to provide those to movie components. So the movie component itself, also quite simple. The first thing in the render function, you see that it grabs this.props and it grabs the movie object from there. So it takes the props as input, it grabs whatever is supposed to be on there, and, sorry, I need to move here. It can actually determine what should be on there. So we can say, well, the movie component has a prop types collection, which is the props which are required or optional, in this case required, for this component. So it needs a movie, and that needs to be an object, and it's required. Which is kind of useful, because if you forget to pass something, React will actually start spitting out warnings to the console, and will tell you, well, expected property movies is not, or movie in this case, is not provided. So these declarations are kind of useful. Well, I didn't actually highlight the code, but in here there is the code where it's actually being used with curly brackets, etc. And the actual layouts of components. So that's kind of nice. We've got components, component tree, we've got data flowing around with props, but you shouldn't change props. And that's kind of like, well, I can render an application with a set of data which I can't change. Well, I'm not going to get a very dynamic or useful application. So we need to be able to change stuff. Just like with reactive programming, you've got that stream of data coming through. Well, we've already seen that we don't really have that, but we need state events. So we can also start working with state in React. And state is not something external, it's not a stream of state. It's basically every component can maintain its own state. It can do whatever it wants with state, it can change it can pass it on to child components, but basically each component can do whatever it wants. So it's really fragmented. You can have one component here with state, another component there with states, which don't know anything about each other, and they can do things independently. So definitely not very reactive there. So what does that look like? Well, I've got a simple component here, which declares in its constructor, it's one of those class types again, its state. So it says it's got a state property, and it starts off with the movies property in there, which is no data yet. You could turn that into an empty array or whatever you want, just an example. And then in the lifecycle functions, in this case the component did mount, which fires just after the component was added to the DOM tree for the first time. We call the fetch function, so the new fetch API to do an AJAX request, and then eventually we call this .set state, which basically says, okay, this component has changed its state, so that movies state, which started off as null, is presumably as a result of this Ajax call now an array of data. The state has changed, and all child components are going to be re-rendered as a result of that. Whether they actually need to re-render or not, React doesn't know. So by default, it's going to re-render all of them. You can actually prevent that using other lifecycle methods, so you can optimize things a lot better. But if I kind of look at this and those lifecycle methods and setting and maintaining state for a component, I'm very definitely out of the reactive ballpark. There is nothing reactive about this. Yeah, sure, it's going to react to events happening. In this case, a loaded event, component with mount. What could happen as a result of a click event or anything on the button. But it's no longer a single steady stream of data to react to. But keeping all that state inside of components works if your React application is kind of small. If your React application gets to be bigger, more complex, it's typically best to move the state outside of React and maintain it separately and just pass it onto React. There are a couple of different ways you can do it. And the most popular one these days is Redux. Created by Dan Abramov, it's one of the many Flux implementations. And Flux is kind of the architecture Facebook came up with, saying, well, if you want to work with data in large applications, you should do it this way with the unidirectional data flow and everything. And they kind of gave us a sample implementation, but it wasn't very good. And lots of people started creating Flux implementations. So at a certain point, there were like a dozen competing. Until then, Abramov came around and he created Redux, and that pretty much instantly became the most dominant one and is used all over the place. I use it in most of my React applications. So what's Redux? Well, as Dan calls it, it's a predictable state container for JavaScript applications. So it's not even specifically for React. Redux by itself is a standalone library, and there is a Redux React library which kind of combines the two. But you could potentially use this in Angular or with any other library. And the principles behind Redux is, so it's a simple source of truth. So we're not going to maintain state all over our application in different components. We're going to have one store, one data store in our application. It's responsible for storing the data. It will be updated. It will notify React components when it's updated. But no longer maintaining state all over the place, because that's hard to maintain. Another principle is state is read-only. One of the problems with JavaScript applications is that just changing random properties on objects, like I might have a movie list, and then I've got a movie in there, and it's got a title, and then I just change some title on some movie in that list. That makes it really hard for applications to figure out, okay, what do I need to update? Because the movie list didn't change the array, it's still the same object. The movie objects in there didn't change, it's still the same object. It's just a string somewhere nested deep down which changed. Well, Redux says, well, if we use immutable data, whether we actually use immutable JS or something like that, or just immutable principles, it becomes a lot easier to reason about what changed or not. So, well, you don't actually have to do it, it's highly recommended to use immutable principles and make things a lot easier. And all the state changes in the Redux store are made with pure functions. And the signature is really simple. You fire actions, they get dispatched to the store. And the state of the application is the previous state with an action dispatched. So old state plus action equals new state, which is a really simple functional paradigm, which is really easy to work with and makes it really easy to develop and test. So what does Redux look like? Well, you create the reducers to actually match that state, and actually go back to the top. If you're going to see this, the function to-dos, which reduces, takes a state and an action as the two parameters. And in this case, the state actually starts off as an empty array if there is none yet, which is the first time. And in the case of toggling a to-do, for instance, we've got a map over the state collection, and if the specific one we're interested in is being toggled, we use object.assign and start with a new object. So we're never mutating existing objects, we're creating a new state object or a new to-do object and changing the properties from there. Which means that React can be quite efficient about what changed, what didn't change. It doesn't need to re-render lots of stuff. So that's kind of nice. It's quite functional, very functional approach to data, but still not very reactive. Now, it turns out that Redux is the most popular way of working with data, but there is another one created by Michael Westerlaten, another Dutch guy, and that's called MobX. And that's not quite as popular, but in my opinion, it should be way, way more popular than it is. And it is relatively popular, but it's like, compared to Redux, it's probably 75% of the people use Redux and 25% use MobX. It's kind of like the only two players left in town, but MobX should be bigger than Redux, in my opinion. And why is that? Well, MobX really is reactive. It's basically described as simple, scalable state management. It turns out it's incredibly simple to work with and creates very fast and reliable applications. So the basic principles, just like with Redux, single source of truth. Keep your state outside of your components, makes it easier to maintain, easier to test. State becomes observable. Now we're into the reactive stuff. It's an observable. We can subscribe to changes, and we get notified if the part we're interested in is changed. Unlike with Redux, which basically says, well, we're going to basically tell the whole React application to re-render itself, and individual components can say, well, except my data isn't changed, so I'm not going to re-render. In this case, it's turned around. It's like only the stuff which is changed needs to be re-rendered because it's observing individual pieces of data which have changed. And React components, they become observables. Or sorry, observers. They observe individual pieces of state. And it's kind of, if you look at React, it kind of feels like, that must be really hard to implement. Well, if you look at the MobX code, MobX code is not exactly easy reading. It's not like, well, it's 11:45, almost bedtime, let's read this source code. At least not for me. Maybe I'm not smart enough for it, but it is quite tough to figure out exactly what is done in there, but it's quite brilliant. If you look at the code, the first thing is we need some kind of store. Remember, the store is outside of our React components. So in this case, we just have a class, and there are movies and directors in here arranged. But notice these add observable decorations in front. They're basically ECMAScript decorators, which are not officially part of the ECMAScript standard, but a really nice way of doing it. They're in the process of being standardized, so hopefully they will be soon enough. But right now, they're still kind of out there. But using Babel, you can transpile this, and that turns these into observable connections. Now, if you don't want to use these decorators, you can actually do it without decorators as well, but the syntax isn't quite as clean. It's not rocket science, but it's not quite as clean. So creating a single store which is observable, has observable data, is pretty easy. Oops, one button, sorry. Creating components which are observers is almost as easy. Import observer from MobX, the observer function, and just wrap your components in the observer function. Now this becomes an observer, and it can be notified of changes. Nothing more to it. In this case, I'm just using a function. You can actually use the same decorator style as well. So if you've got a class or anything, just put add observer, I should say, above it, and it will do exactly the same. And now it will be updated. You can declare exactly what you need, and it will just work. It will only update whatever is really needed, so it's much faster. So this is kind of reactive. Is this React? No. It's MobX. But it works together with React in a really nice way. And it does mean that React applications kind of become observables. So is React reactive? Well, I guess everyone can guess the answer by now. No, it isn't. Is that a bad thing? No, not everything needs to be reactive. It's a great UI library. I really love it. I use it a lot for web applications. It's perfectly good for that, even if it isn't reactive. You want to use reactive programming, use MobX. You want to use more complex data, use Redux. But use either of the two unless you're doing a real trivial application. I kind of go with a more complex application where there is a lot of stuff going on with data. I tend to go with Redux, and if the data is somewhat simpler and easier, then I tend to go with MobX because it's so easy to set up. But either will work really well. So, with that, I'm at the end of my presentation. If there are any questions, feel free to ask them now or later. I'm not going to be gone. Or just tweet them out to me tomorrow or sometime. Or check my Twitter account for when I post the slides in slide share. And they'll be there. Yes?
So you mentioned that you decide on whether to use Redux or MobX,
yes,
depending on the complexity of the data that you have to use. No?
Yeah, it's kind of like if you've got relatively simple data coming from maybe one or two AJAX requests, then just storing everything in MobX is easier, because then Redux kind of means you have to create actions, you have to start using Redux Thunk or another way of asynchronous working with it, because Reducer has to be idempotent, so it can't do an AJAX call, because then there is some kind of side effect there. So all of that becomes more complex. So just using MobX is a lot simpler. Now if you're doing a lot of complex manipulation on your data, then the immutable principles of Redux actually become more beneficial, and it becomes easier to unit test all of that. And in that case, I favor Redux over MobX. Because MobX is kind of, well, you change something and everything is just updated. It's kind of magical, which is good in a way, but harder to test. Other questions? Yes?
When you think about upgrading the React framework, normally, I don't like upgrading all the JavaScript frameworks. And do you have experience? Do you have an opinion about that?
For the most part, upgrading versions of React has been quite smooth. There are things which break, but they don't break all of a sudden. It's kind of like if we went from 0.14 to 15, which is kind of a big jump, but the 0.14 kind of assumes it was preview or indicated preview stuff, while it was in production for quite some time, so they kind of jumped to 15 there to indicate that it was mature, and stuff changed. But in the previous version, they actually already included warnings about it, so you would see console log messages about stuff which would be deprecated in the future. They're quite open about it, even in documentation now there is stuff, well, you can use this now, but it will be deprecated in the future. Like one way of creating components right now is using React.createClass. And that still works perfectly fine, but they've publicly said it will be deprecated sometime in the future, and the mix-in support along with it. Not sure when, but if you ignore all those things, yeah, then you're going to run into, okay, now I want to upgrade and my stuff doesn't work because I'm still using that. If you upgrade version to version and keep fixing those warnings, then very little problems. And the other, yes.
You mentioned React Native in the beginning.
Briefly, yes.
Briefly, but what are the restrictions if you compare it with native development of iOS and Android?
It's kind of similar in a way and kind of completely different in another way. Which is kind of a
Very
vague
vague
answer. Very vague. So let me explain that a bit more. If you do React Native, you're still using JSX and you're still returning components and you've still got the same way of working with data, with set states, working with props and the same lifecycle events. So a lot of that is similar. The thing which is very different though is you don't render divs because they're for the browser. You render components. And it turns out that some of those components for Androids don't work on iOS and the other way around. So you kind of have to cater for that. And you can actually do that because React Native has some smarts there. If you've got a component called, say, toolbar, you can create a toolbar.jsx. And if you create a toolbar.ios.jsx, it will actually pick up that file instead of the standard toolbar for the iOS compiled version. But they're very different environments other than that. You're really building a native application. It's not kind of PhoneGap where you're using a browser to mimic a native application. You're really using iOS, you're really using Android. Even during development, you need to run against an Android emulator or an Android device, etc. So, other than the JSX and the style of working with things, which is the same, it's completely different. Yes?
And then the end result, is it a bit like Swing, Java, everywhere, or is it kind of
No,
decently baked in?
I'm no Swing expert, so little caveat there. But the stuff I've done with it, which is quite limited, is a real native application with a native look and feel. You can make it different for Androids and iOS. There's actually a version for Windows as well, so you can make a Windows UWP application as well with it. And they all have their native controls, so you can make it look and feel different, but you actually have to take care of that.
You have to know the platform to
Yeah,
make
you have
make
to.
it convincing, otherwise it's just bland.
Yeah, it's not like you create a web application which runs on both and kind of looks the same on both, so it doesn't look native anywhere, which happens a lot with PhoneGap style applications. It would work, mostly, but it's never felt completely native. Yes?
One issue that we have with this meetup is that everybody thinks this meetup is about ReactJS because it's called Reactive Amsterdam, but it's not like that. And so my question is, why the name then? Where does the name React come from?
Ah, good question. I'm afraid I don't really have a good answer because with naming things are hard. Java, JavaScript, just to name an example. How close are those? Well, just as much as car and carpet. Not the same thing. In this case, I don't work for Facebook, so I don't know why they chose the name React. It's not reactive. If you squint hard, you might think of some reactive things there, but it's really not reactive. Is it a coincidence? Maybe. I don't think so, but could be a pure coincidence. Things happen, I don't know. But I don't think they consciously called it React to imply that they were using reactive style programming. Maybe if reactive style programming was really popular, which is the reason with JavaScript. Why is JavaScript called JavaScript? Because Java was really popular at the time that, what was it, Mozilla, Netscape, sorry, shipped JavaScript. Originally it was called LiveScript, and before that it was called, I forgot what, well, never mind, it actually had another name before that. But it was because of marketing pressures, they called it JavaScript. So people would start thinking, oh, it's just a scripting version of Java. which of course we all know is completely bogus. So I'm afraid I don't have a good answer for you, but it's a good question, but other questions? No? Yeah.
Since you glanced over RxJS and the topic is reactive, can you explain how does it fit into that stack?
RxJS.
Yes.
Okay, well, React is purely about components. All it does is render components. Unlike, for instance, say Angular. Angular is a full framework which ships with the kitchen sink and everything. You want to do an Ajax call, Angular has a class for that. You want to do routing, Angular has a class for that. With React, it's components. You want to do routing, well, there is this library called React Router, but it's just a subsidiary thing. It's not for Facebook, and you could use something else. You want to do an Ajax request, you use fetch or whatever, jQuery or whatever you want to use. Well, that's where RxJS comes in for me. I basically do lots of stuff with RxJS, gather data, process it, and then after that's done, it ends up in the state. And occasionally I'll use it for event processing from my React. But it's in my React applications, it's more often doing Ajax requests, processing that, and then turning that into React state. Yes?
You mentioned that the approach of the reactive approach to update states or to register observers
With MobX.
Yeah. Was, I think you mentioned it's like faster, more efficient than producers in Redux. How is that? I mean, how would you create an observer? Because if I'm observing something that, so how does the observer know that the data coming in is something for it rather than another observer? And how? Because I would say both the observer and the parent list, and then how is one faster than the other?
Well, what Redux does is you create a Redux store, and then your root components you wrap inside a Redux provider. And every time a change is made, that Redux provider triggers a re-render of the application. So its child and all of its children will be re-rendered. And they will basically extract the state they personally need from that provider. And that's passed through by something called context, which is kind of a back channel where you can pass data in a React application. But it means that the whole application starts re-rendering, even though for a large part it might not have changed any data. Now there is a lifecycle function, should component update, and you kind of start implementing that from, if the data from my component hasn't changed, then I don't need to re-render. So it's kind of, you start opting out of re-render.
Like collision coding.
Yeah. With MobX, it's the other way around. Components observe individual pieces of data from the store. So it's not that the root components is notified and it re-renders the whole application. It's basically individual components are notified and they re-render, and then their childs will also re-render. So if your root component would actually be an observer, then you would still get complete renders. But usually it's much further down and you don't re-render anything. Like you might have a big list of movies, and in a Redux application, the immutable nature says, okay, now one movie changes, that means that the list changes, so the list has to re-render. Say there are 100 movies in there, 99 haven't changed, so 99 movie components will say, no, don't need to re-render, and the hundreds will say, okay, I do need to re-render. In MobX, the list doesn't need to change. You just assign that one title property on one movie. So the list component doesn't re-render. The 99 other components don't get a notification. It's just the one single movie component which gets a notification.
Or it's a bit like adding a control, like a MVC controller to every widget.
Yeah, a bit. It's not really an MVC thing, but again, if you squint, you could compare it to MVC. Yes.
Right. All right, guys. I'd say, well, thanks, Maurice.